Welcome to Unit 3, Lesson 5, Rational Equations, Part 1, Practice Problems. Okay, a local office supply store charges $18 to set up business card printing machine with 15 per. Here we go. The key word in this sentence is per. Select all equations that represent an equation. So, 15 cents per, that's your rate. So now the first thing we want to do is write the regular equation. 0.15x, because it's next to per, plus 18. I'm not going to worry about the average yet. I'm just going to see which ones have that. 0.15x. Well, B has it. And then something else has to have it. E has it. No, 18 plus x is just over x. All right, now let's make an average out of it. Let's separate the fractions like we did last week. As x gets very large, this eventually goes to 0. Our x's cancel out. Oh, they left it like that, where they left the 18 over x. So F is the proper answer. So B and F are the correct answers. Okay, so we're going to put this expression that they give us into the calculator. So y equals, and then the green button in x, which is right next to each other. And then in y1, you're going to put the term in. And then you're going to hit second graph to scroll down. And so the average logo, so when x is 25, y is 585. When x is 100, y is 165. How many uniforms to get an average cost of $1? So now, average cost is $1. That's 140 plus 0.25x over x. And then when we solve this, we get 1x is equal to 140 plus 0.25x minus 0.25x from both sides. We get 0.75x is equal to 140. We divide by 0.75, and x will be equal to 186.6 repeating. That makes no sense. So we're going to say x is equal to 187. This is our answer. If we put 186, we're going to be just a slight hair over $1. If we put 187, we'll be a little bit under $1, but we would rather be under than over, because if we're over, we'll lose money. So 187 is the better number. Okay, I had to put number 4 on the next page. So for D, what's our asymptote? We're going to separate the fraction. We cross out the x. We're just left with a quarter. So as the number of uniform increases, our cost per logo goes down to 25 cents, or 1/4 of $1. Okay, 2 competing sports suppliers sell footballs at different prices. Okay, now keyword per. $2.59 goes with per, and $4.29 goes with per. So what we're going to do is set these equal to one another. So we got 2.59x plus 85 over x for A, because we want average cost. See, average cost is an average. B, for supplier B, you get 4.29 plus 50, 4.29x, I'm sorry. And I forgot the x. Plus 50 over x. All right, put these in the y1 and y2. Put A in the y1. You hit alpha x to make it a fraction and put your numbers in. And then when x equals 40, what is y? Okay, so after we hit second graph, we scroll down to 40. supplier A at 40 balls is about 4.72 per ball, because we're dealing with money and you can't have 3 digits behind a decimal, so you have to round to 2 digits. All right, for supplier B, we're about $5.54 per ball. So I would choose supplier A because it's cheaper per ball. It gives you a cheaper overall cost, overall average cost. Okay, the first way to solve this problem, put them in the calculator. In the Y1, put parenthesis x plus 6, close it, open another one, x plus 2, and then in the Y2, put x plus 6. His second graph, scroll down in X. You're looking for where both the blue and the red, the Y values are the same. And you'll see that the X is 1 when Y1 and Y2 are both 5. Now, for those of you that want to solve it algebraically, all right, now, there's no coefficient in front of the x, so x times x becomes x squared. To get the middle term, we add the constants, which gives us plus 8x. To get the last term, we multiply the constants, which gives us 6 times 2 is 12, equals x plus 6. Subtract x, subtract 6, subtract x, subtract 6. We get x squared plus 7x plus 6 is equal to 0. We get x plus 1 and x plus 6 equal to 0. Now, how do I know that? I take the factors. What numbers multiply to make 6? I add them, I subtract them, and the one that gives us 7 is 6 and 1. So when I change my sign, I get x equals -1. I get x equals -6. -6 is not an option. -1 is. I can stick -1 back into both equations. I will get +5, but I don't need to do that because -1 is my only option for B. Okay, so now this goes back to polynomials. The graph of the polynomial 5x minus 3, what you had to do is set each factor equal to 0, and when we add 3, we get 5x equals 3, divide by 5 on both sides, x equals 3/5. We set x plus 4 equal to 0. Subtract 4 from both sides, x equals -4. And then we set x plus a equal to 0. Subtract a from both sides, x equals -a. Our a was 6. We stick it in there. We get -6, which makes -6. So the value of a is -6. Or flip the signs. Now, the 3/5 is a little different because you got the coefficient in front of x. This comes from last week. All right, so now, the function can be written in the form of 3 over plus -22 over x plus 6. What is the behavior? So our constant term is the end behavior. So y eventually our horizontal asymptote, because when y is equal to a constant, we get a horizontal line at 3. Our asymptote is 3. That means the function goes to 3. How do I know that? So if I take 3x minus 4 and I divide it by x plus 6, I get 3, giving me 3x and 18. I change both signs. I get -22 as a factor. So that gives me 3 as a whole number minus 22 over x plus 6. And that's how I get that one. So my whole number becomes my horizontal asymptote. In order to find a horizontal asymptote, you long divide. So that's sideways. So if I had to graph it, I would have a line that will not show up on the calculator. Then my vertical asymptote, I set the denominator equal to 0. And that gives me x equals -6. And so I get another, and then so I get something like this. where this is 3 and this is -6, and I get something like that. You can graph it in the calculator. It's going to look close. You will not see the dotted lines in the calculator. You won't see it, so don't look for it.